All right, now practical applications of a sequence, okay? So let's say we wanted to consider monthly compounded bank interest. Okay? And let's say we want to do monthly compounded bank interest, and let's give this bank account, well, let's call it a savings account, and let's give it an interest rate. Okay? So if I say that the interest rate is going to be a 0.2% interest rate. Okay. Now, this type of interest rate is not that uncommon. Honestly, my savings account, I have a 0.25% interest rate. Okay. Now, let's look at what is actually happening. So, let's say the amount that you invest in your account is P naught, and we will refer to this as the principal amount. All right. So, let's consider this actually as a sequence. So, what would happen at the very beginning? We'll refer to this as month 0. Okay. Now, at month 0, you just put that money into the account. That's all you've got is the principal amount. Okay, so that's just money that you put into your savings account. Okay. Now we have monthly compounded bank interest. This means that it's going to be compounded 12 times because we have 12 months in a year. All right. So the first month you put the principal into the account, nothing happens, it just stays there. Okay. So now what happens after month 1? Okay. Well, after 1 month, it's going to take the principal amount existing within your bank account. Okay, so P naught was already inside of it. All right. And what is it going to add? It's going to add the principal divided by 12 and then multiplied by your interest rate. But if you turn that percentage into a decimal, that's 0.002. Because it was a 0.2% interest rate. So you have to move the decimal up 2 spots. Okay. Now let's think of a way that I could reword this. In this problem involving compounded bank interest, what you want to think on every time you do this problem is, what can I pull out of this? Well, what can I pull out of this thing is the principal of the interest. I mean the principal, not the interest. So, at month 1, we would have the principal amount within the bank account multiplied by 1 plus 0.002 and then divided by 12. Okay. So at a 0.2 interest rate, it takes the principal amount in the account, divides by 12, and multiplies it by the interest rate. All right. Let's see what happens at month 2. Okay, so this is the amount in the bank account at this point. So now we're going to consider month 2. So there is this amount within the bank account. Okay, that's just for month 1. All right, and so what am I going to do? I'm going to take, well, I've already got that amount in the bank account. Okay, so that is already in the bank account. And then what am I going to do? I'm going to take that amount that is in the bank account, and I'm going to add the amount that was in the bank account already a little bit. I'm going to take that amount right there. I'm going to divide it by 12, and once again I'm going to multiply it by the interest rate. Okay. Now, when looking at month 2, once again, you have to ask yourself, well, what is something common between these two things that I can actually pull out of it? And actually, I want to label these. We'll start this as, you can label this as P of 1. Okay, and we're going to try to figure out what P of 2 would look like. So, what can I pull out of this thing? Well, P naught is common for both of those, and so is 1 plus 0.002 divided by 12. And so that would become, so what am I going to pull out? I'm going to pull this, I'm going to factor that and that out. All right. So, that would become, all right, now P naught 1 plus 0.02 divided by 12, and then multiplied by 1 plus 0.002 divided by 12. Okay. And so that would equal P naught. And so that would be my P of 2 at month 2. Okay, so at the end of the second month, this is the amount in the bank account. And let's see what happens when we go to month 3. Well, some people are still working on it, have a chance to get caught up. All right, now we're going to repeat the same procedure. So for month 3, okay, so month 2 is passed. Now after month 3 is passed, what do we have in our account? We have Now, this is just what we have left over from month 2. Alright? And so on month 3, what is it going to do? It's going to do the same thing. It's going to take the amount of money in the account, so it's going to take the amount of money in the account based upon the second month, and then it's going to add in the amount of money in the account after the second month, divided by 12 and multiply it by the interest rate. Okay. So now, what happens with this? There's something common between both of these that we can factor these out. And so, this would equal P naught times 1 plus 0.002 divided by 12, now squared, and then multiplied by 1 plus 0.002 divided by 12. And now we can combine these. And so that is going to equal the principal amount times 1 plus 0.002 divided by 12 raised to the third power, and that becomes P of 3. And this procedure continues on and on. And so, just from looking at this, if we can figure out what P of K would be. Okay. So, P of 2 is P naught times 1 plus 0.002 divided by 12 raised to the second power. Then P of 3 becomes it raised to the third power. So, what is P of K? The generalized sequence. So this is just the general formula given in months, but this is not how this formula is normally given. Okay. So how is this formula normally given? All right, so in any business math class, you normally see the formula written like this. And in this specific case, R would equal 0.002. N would equal 12. Okay. Then T would be time in years. And so why would this one become important? Because, well, there's 12 months per year. Okay, so for other cases, let's say it was compounded daily. What would N be? It'd be 365 because there's 365 days per year. Okay, so if you multiply that by the number of years, it gives you that formula. Okay, so this is a specific instance of a sequence that occurs. I mean, so this class is discrete math, and so if you're thinking about it, yeah, this is just occurring discretely every single month. Or if it's occurring daily, yeah, it's occurring every single day. Think about it, well, what would be happening every single day if your bank account was being compounded daily? It would take the amount in the bank account divided by 365, multiply by the interest rate, and go ahead and add that into the amount that was already in the bank. Okay? If it's compounded, but there's another question. Y'all might not have seen this formula, but in business mathematics, this actually gives rise to another formula, which I am not going to prove to y'all in class today because it goes. Oh, I'm going to prove it to my students in my calculus class right after this, but you actually need derivatives to do this. Okay? And so one of the questions becomes, what happens if I take the limit as n tends towards infinity? Okay, so if I take this formula right here and decide the limit as n tends towards infinity of P naught times 1 plus R divided by n raised to the nt. This would equal P naught e to the RT. And what is this formula? All right, so when talking about the difference between discrete mathematics and something that is continuous, this formula tells us that at any point in time, we can calculate the amount in that bank account. And so what is happening, instead of the bank interest being compounded discretely, hence every single month, it's actually compounded every single second of every single day, not just every single second, because that would still be discrete, but every single millisecond. It's being compounded continuously. So at any point in time, let's say at a point in time which is t, which is, I don't know, 3.5 years. What could you do to this problem? You could just plug 3.5 into that and it'll tell you the exact amount in your account. So this is the difference between things that are considered discrete and continuous. This continuously compounding bank interest, it's going on constantly. Okay? It's not going over discrete intervals. Okay? So this is an example of, you take something that is a sequence, and then it actually, if you take the limit as n tends towards infinity, it becomes continuous. All right? That'll make it easy.